Hello everyone, this is Dennis, and you are on the Electro channel. Today I will be reviewing such a compact, multifunctional DC tester. It makes all the necessary measurements such as voltage, current, power, temperature, and many more. This device also has a large supply voltage range from 8 to 120 volts. Measured voltage from 0 to 200. The maximum current that it can pass through itself is 10 amperes. It can be integrated into various devices, such as power supplies, at least a homemade factory move, or chargers. There is a counter here that records how much current is poured into the battery, and naturally, after charging, you can calculate the battery capacity. Now I will show you how to connect it, tell you all its advantages, show you how to use it and test it. The tester looks like this. It is a small black plastic box with dimensions of 85 millimeters by 44. Thickness 21 millimeter. On the front panel, there's only one button labeled Menu. The panel is made of a very thin plastic that flexes easily under finger pressure, so that after installation in some device, the tester does not hang from above and latches are provided from below. On the back wall, there is a sticker with a wiring diagram with two power supplies. To the left of it are two connectors. 3 thin wires are inserted into the lower left. Tester power supply and voltage measurement. And 2 thick power leads are inserted from above to measure the current strength. Below, there is another small connector where the temperature sensor is connected. The body of the tester consists of 2 halves, which are mounted on 4 screws. I remove the back wall and a large board immediately catches my eye, occupying the entire space of the case. By the way, there is a protective film on the glass against scratches. If desired, it can be removed to make the glass shine. On the left, the designation of the connected wires is written. In the middle is a color liquid crystal display measuring 45 by 25 millimeters, and on the right is a single button. Behind is a lot of electronic devices. Some of them are occupied by the H6203 switching buck converter. It is to him that we owe such a large range of supply voltages from 8 to 120 volts. The output of this converter is always a constant voltage of 5 volts with a maximum current of 1 ampere. His circuit includes a 47 microhenry inductor, and two capacitors for 470 microfarads, 10 volts, and 10 microfarads, 160 volts. The KWS 1622 chip is similar to the MS501FB9AE display control driver. This is an 8-bit microcontroller with memory and RAM. It contains the firmware of the tester. To the right of it is another small chip labeled a 63A. Under this code name, the LM321 operational amplifier is hidden. And to the right is a large 1-watt resistor marked RR005. Its resistance is 0.005 of an ohm. In this tester, it also acts as a shunt. When current flows through it, a voltage drop occurs, and the tester measures it, converting the readings on the screen into amperes. There are also several diodes on the board. One small one marked WH is a 12-volt Zener diode, and three larger diodes marked SS3150. These are Schottky diodes for 150 volts, 3 amps. There are also 3 controls on the board. 2 of them are potentiometers. One regulates voltage and the other regulates current. They should be used if the tester readings do not suit you. With the help of them, you can adjust the voltage and current more accurately. Above them is a reset button. With it, you can reset the ammeter readings. But you need to press it only in those cases when the ammeter is idling. That is, without a connected load, it shows some current. If the ammeter, as expected without load, shows zeros, then the button does not need to be touched. Near the connector where the temperature sensor is inserted, there is an inscription, NTC10K3950. This means that a thermistor with a resistance of 10 kiloohms with a negative temperature coefficient is inserted there, and its marking is 3950. The temperature sensor attached to the tester looks like this. Its wire is not very long, about 40 centimeters. At room temperature, the resistance of the temperature sensor is 9 kilo-ohms. If I touch it, the temperature starts to rise and its resistance drops. This fact confirms that the temperature sensor is based not on the topic of steam, as many used to call it, but on a thermistor. There are 6 sectors on the screen with different parameters. Measured voltage, power, temperature, measured current, and time. On the last line is the ampere hour and watt hour counter. If you press the menu button, you can switch between these options. The ampere hour meter is very handy when charging or discharging any batteries. You can find out how much current is poured into the battery and therefore calculate its capacity. The temperature sensor works great. When I touch it, the temperature starts to rise. If the temperature sensor is pulled out, the temperature sector will be empty. The tester is sent in a small box and has such instructions in Chinese and English. It has such a table with the characteristics of all models of this tester. My device is in the first column. Model KWS DC200-10A. the voltage that the device can be powered from 8 to 120 volts. The voltage of the tested power supply is from 0 to 200 volts. The maximum current without using an external shunt is 10 amperes. The maximum measurement power is 1200 watts. Here, of course, a little is written incorrectly, since 1200 watts is apparently using power from a single current source. This is at a voltage of 120 volts and a current of 10 amperes. And if you use two separate power supplies, one for the load and the other for the tester, then at a voltage of 200 volts and currents of 10 amperes, the power transmitted through the tester will be 2000 watts. Next are the parameters of two counters for ampere hours and watt hours. The maximum timer time is 200 hours. Temperature measurement from -9 to +99 degrees. The instructions also show two connection diagrams. One with two feeds and the other with one. First, let's analyze a circuit with two independent power supplies. There are two blocks to be used here. One weak power supply to power the tester, and the second powerful power supply to power the load. A weak power supply is connected to two thin wires of the tester, red and black. It should have a voltage of 8 to 120 volts. The plus of a powerful power supply is connected to one load contact, and the second load contact is connected to the thick red lead of the tester. The black thick wire of the tester is connected to the minus of a powerful power supply. Thus, the current will flow from the plus of a powerful power supply through the load. Then it will pass through the tester and go to the minus of the power supply. The yellow thin wire coming out of the tester measures voltage. It must be connected to the plus of a powerful power supply. In more powerful versions of this tester for 50 and 100 amps, the only difference in connection is that the remote shunt is connected to the black and red wires. These versions do not have an SMD shunt that is built into the tester case. And therefore, the current will flow only through the external shunt. This circuit is convenient in that the range of voltages used can be varied from 0 to 200 volts. But the downside is that you need to use two power supplies. Now let's move on to the wiring diagram with one power supply. Everything is much simpler here. The power supply must be used from 8 to 120 volts. If the voltage is less than 8 volts, the tester will not turn on. It is impossible to raise the voltage above 120 volts, since this voltage will come not only to the load, but also to the tester. Also note that although this photo is taken from the documentation that came with the tester, there is still an error here. It says that the connected power supply must have a voltage of 0 to 200 volts. It is not right. In this connection diagram, the red thin wire coming from the tester must be connected to the plus of the power supply. The yellow signal wire, which measures the voltage, is also connected to the plus. A thin black wire is not connected anywhere, it will hang in the air. In all other respects, the circuit is exactly the same as with two power supplies. This circuit is convenient in that only one power supply is used here. But the big minus is that the voltage range used is only 8 to 120 volts. I will show in practice how to connect a tester with one power source. The plus of the power supply is connected to the red thin wire. The minus of the power supply is connected to the black thick wire. After that, the device turns on, but does not yet measure the voltage. To fix this, you need to connect the yellow wire to the plus of the power source. Now you can see that the input voltage is 12.5 volts. Black thin wire is also a minus. And if you connect it to a thick black wire, then nothing will happen. But it is not recommended to connect it when using a single power source. For load, I will connect a small 12-volt light bulb. At one end, I attach it to a thick red wire. And the second on the plus of the power supply. The light bulb immediately lit up and the current went through the tester. The device immediately captures the passing current and calculates the power of the light bulb. With two power supplies, the connection will be as follows. A weak power supply is connected to a thin black wire and to a thin red wire. The minus of a powerful power supply is connected to a thick black power supply. The plus of a powerful power supply is connected to the yellow measuring lead. Please note that after this, the tester immediately captures the incoming voltage. The load is connected at one end to a thick red power lead, and at the other end to the plus of a powerful power source. With two independent power supplies, the voltage can be adjusted to a minimum. Thanks to a separate power supply, the tester will not turn off. I can't say anything about the measuring accuracy of this tester, since I don't have any super mega accurate reference device with which to compare it. But if anyone is interested, then here is a comparison with the ZK5KX converter. Both devices show the voltage almost the same, and the current strength in hundredths is slightly different. At a voltage of 36 volts, both show the same. Next, I will show how things are with heating when changing the maximum current strength. I glued the temperature sensor to the shunt with tape to record its heating. I apply the load and gradually increase the current. Here I sped up the video 3 times to show how quickly the resistor heats up. To begin with, I will give about 9 amperes. In about 10 minutes of operation, the shunt heated up to 49 degrees. The board on the back of the shunt is also hot. The wires are also hot. I'll try increasing the current and see what happens. Although the tester is declared as 10 ampere, in fact it can show more. In this case, almost 12 amps. I will not increase it anymore, since the shunt is not designed for such power. If the power of the tester is turned off, then the time counters for watt hours and ampere hours are not reset. After switching on, everything is saved. To reset the readings, hold down the menu button for 3 seconds. After that, all counters are reset. I have noticed that this instrument has a slight delay in updating the readings, but this will only be noticeable under dynamic loading. Suppose when measuring the current consumption of some audio amplifier. If you connect some kind of light bulb or some other resistive load, then the effective reading lag will be almost invisible. Now I will connect the load. Look carefully at the screen and at the light bulb. The power is 93/100ths of a watt, and the current strength is 80 milliamps. When I turn off the light bulb, the tester updates these readings very slowly. In fact, there is no load anymore, and the tester still shows some small part of it. Look at it again. The slow refresh rate is only seen on watts and amps. There is no such thing as voltage. When the voltage rises and falls, it is updated quickly, just like on a laboratory power supply. I will leave a link to this tester in the description. As always, please like this video. Subscribe to my channel if you have not subscribed yet. Click on the bell so as not to miss new videos. And write comments, ask questions if someone does not understand something. That's all for today for now.